Okay, we're ready to start our new unit, which is on conics, parametrics, and polar graphing. So some of these are going to be new to you. The beginning of conics, though, I think is going to be a review. So I'll go through that rather quickly, and then you can always pause and if you need to work through some stuff. So the first type of conic that we're going to focus on is circles, something you've seen before. And there's a couple different ways we can define circles, but let's use the geometric definition. And a circle is a set of points in a plane that are equidistant from a fixed point, which we call the center. So don't think of a circle as like a curved line, just think of it as an infinite set of points that are all the same distance away from a center point. The distance between the center and any point on the circle is the radius, and we denote that with an r. So if we put it in the xy coordinate system, then we'll let the center of the circle have the coordinates h comma k, and then any point on the circle we'll call x comma y. So we could actually set up an equation using the distance formula between those 2 points. And so that'll give us the distance, which is r, will equal the square root of x minus h squared plus y minus k squared. And then if we square both sides to get rid of the square root, we get what we're familiar with, the standard form for the equation of a circle. And so the quantity x minus h squared plus the quantity y minus k squared equals r squared. Now it's important that you understand that when it's written this way, so let me throw in a particular number. If I have x minus 2 squared plus y plus 7 squared equals 25, the h is equal to 2, positive 2, and the y is equal to negative 7. So you can think of y plus 7 as y minus a negative 7. So in our standard form, this is a minus. So if you see a plus, you have to think of it as minus a negative. And make sure that you understand that h is 2, k is negative 7. So the center is 2, negative 7. And then our radius is 25. Alright, so let's take a look at some examples. We'll start off with some easy ones, so I'll move through them quickly. What's the center and radius of this circle? And by the way, as you work through these, you could download the PDF and you can work through the skeleton notes and write on them. I recommend as I go through the different examples that maybe you pause and try and write down the answer or figure it out first, and then go ahead and hit play again and see if your answer matched the correct answer. It's better than just passively watching me work through problems. It's better if you actively engage in each example. Okay, so, and this is I think rather obvious, but if you think of our general formula, there's no parentheses in this problem. And that's pretty sloppy. But this problem that was given to us, the x squared, you can think of it as x minus 0 squared plus y minus 0 squared. And then 10 I can think of as the square root of 10 squared. So the center, in this case, is 0, 0, and the radius is the square root of 10. The radius can't be negative, so we don't have to worry about plus or minus root 10. Let's look at another example. What's the center and radius of this circle? So we have the h is 1 and the k is a negative 4. So the center is going to be 1 comma negative 4, and your radius equals 6, which is the square root of 36. Okay, so you should be able to look at the equation of a circle and give me information about it, and vice versa. You should be able to, if I give you information about a circle, write the equation of the circle. So when you're reading these, and I've mentioned this throughout the year, it's a good idea to always write down what your answer should look like before you dive into all the details. So write the standard form for the equation of a circle. So right away over in the corner, I'm going to write what my answer should look like. And now I'm going to see what information they gave me so I can figure out h, k, and r. Well, this one's really straightforward. So we have x minus a negative 7, so x plus 7 squared. Since k is 0, you don't need to write y minus 0 squared. You can just write y squared. And no, I know a few of you are wondering, if I wrote y minus 0 squared, would you mark it wrong? No, I would not. And the radius is 4, so 4 squared is 16. If you wrote 4 squared, that's okay, but generally we're not going to leave it in that form. We'll go ahead and square it and get 16. Alright, so let's try something a little different. Write the standard form of the equation of a circle if I give you the endpoints of a diameter of the circle. So, start out one step at a time. What is our answer going to look like? It's the standard form for the equation of a circle. So I know that my answer needs to look like this. Did they tell me what the center of the circle is? No. Did they give me the radius? No. But, as usual, there's enough information there to figure that out. So let's do this. Let's get a visual. And let's graph this. So -5, -10. Let's say that's over here. And +1, 4. Let's say that's right about there. So this is the diameter of a circle. Not the best, but not bad. Okay, so we need the center of the circle, which is somewhere right over here. Now, we should realize that the center of the circle is going to be the midpoint of that diameter. So, if you remember how to get the midpoint is the average of the x-coordinates and the average of the y-coordinates. So my x-coordinates are -5 plus 1 divided by 2. That'll average my x-coordinates, and then I'll average the y-coordinates, -10 plus 4 divided by 2. And so that actually is the midpoint formula for a segment. So when I simplify that, I get -4 over 2 is -2, -6 over 2 is -3. And if you look at the picture, -2, -3, that seems about where it is in my picture, and it's not a perfect picture, but it's close enough. So if you make a mistake, usually by having this picture, even if you don't spend a lot of time drawing it, you'll realize if it's close to the right answer or if you made a silly mistake. Alright, now remember what our answer is supposed to look like. We're trying to get the equation of the circle. So all we found so far were the h and the k. We still need to find the r. So there's two ways we could do this. The radius is half of the diameter, so we could find the distance between these 2 points and then just cut it in half. Or we could use our center point and either of the other 2 points and use the distance formula on those two to find r. So let's do that. So r is going to equal, if I have enough room here, not a lot. So radius is going to equal the square root of the difference of the x number squared. Now I'm looking at this point and this point. So -2 minus 1 squared plus the difference of the y's, -3 minus 4 quantity squared. So that gives me the square root of -3 squared, which is a +9. These numbers should always wind up being positive because we're squaring them. If you punch things in on your calculator and you don't put the -3 in parentheses, you'll get -9 on the calculator, which is not correct. And then -7 squared is 49. I add those together, I get the square root of 58. Now, I realize that I'm supposed to write r squared in my equation, so r is equal to the square root of 58, so r squared is just going to be 58. The squared cancels the square root. So now we're ready to write our answer. Let's make some room over here. put it right up here. So final answer is x minus h, so minus a negative 2 squared, plus y minus k, y minus a negative 3, so y plus 3 squared, equals r squared, which is 58. And there's the equation of the circle that has a diameter with those endpoints. So that one took a little bit more work, but still not too terrible. Alright. Quite often you're going to see problems like this where they give you the equation of the circle, but it's not in standard form. So what we need to do is put it in standard form so we can pick out what's h, what's k, and what's r. Alright, so we've done some of this already this year. We have x squared minus 2x, and then plus something, and then we have plus y squared minus 4y plus something else, and then that negative 4, I'm going to move that to the other side, and so I'm going to have positive 4 on the other side of the equal sign. Now if you remember, how do we fill in the blanks so that we have a perfect square? Because what we're looking for is that we want to have a quantity squared, not necessarily a plus. We're going to have x something squared, and then we're going to have plus y plus or minus something squared, and then equals our r squared. So what we need to focus on for the x part of it is look at the coefficient of x to the first power. We divide that by 2 and square it. So negative 2 divided by 2 is negative 1, squared is positive 1. Now, x squared minus 2x plus 1 factors to x minus 1 times x minus 1, which I can write as x minus 1 quantity squared. So I've completed the square for the x terms. Now we'll do the same thing for the y. Use a different color. So we look at the coefficient of y to the first, divided by 2, and then square it. So that's going to be a positive 4. So when you factor y squared minus 4y plus 4, that factors to y minus 2 times y minus 2, which we can write as y minus 2 quantity squared. Okay, now we're dealing with an equation, and that should have been green. We're dealing with an equation, so we can't just add or subtract stuff to one side of the equation. So if you look back, what we did was we added 1 for that, and we added 4 for that. So we added 5 total to the left side. So that means that we need to add 5 to the right side as well. So now what we have on the right side is 9. And so now this tells me that the center of my circle is at 1, 2, and the radius, well, the radius squared is 9, so the radius equals the square root of 9, which is 3. And now I'm ready to graph this. So the center is at 1, 2, right there. And if the radius is 3, I usually like to plot 4 points to make my circle. So from the center, I'm going to go 3 to the right, because I know exactly where that is. 3 up, 3 to the left, and 3 down. And now I can try and make my circle for this. There we go. Not bad. Okay. And let's try one more problem. Find the x and y intercepts of the graph of this circle. So once again, maybe a quick graph will give you an idea here. So the center of this circle is negative 2, 1. Negative 2, 1. And the radius of this circle is the square root of 10, which is a little bit more than 3. So 1, 2, so maybe about there, and about there, and over there, and over there. So roughly this is what we're looking at. Okay, now if you notice, this crosses the x-axis at 2 points, and it crosses the y-axis at 2 points. Now sometimes you'll have problems where the circle won't even cross either of the axes. So you want to keep that in mind. And also sometimes it'll be tangent to one or both of the axes. So then the intersection will just be 1 point. So we could have 0, 1, or 2 answers for each of the intercepts. Alright, so how do we find the x-intercepts? Well, if you remember from back when we were working with functions, we're going to set y equal to 0. Because every point on the x-axis has a y-coordinate of 0. So we're going to take our equation of the circle, and we're going to plug in 0 for y. And then we just need to solve for x. Now notice we have an x squared term, so we should get 2 answers. Now there's 2 ways we can deal with this. I'm going to do it, I think, the easier way. So x plus 2 squared, I'm not going to square that. In the other parentheses I have negative 1 squared, which is positive 1, and then I'll subtract that to the other side. 10 minus 1 is 9. Now, instead of expanding out the left side, and then moving the 9 over, and then using factoring or quadratic formula, it's easier if I just take the square root of both sides right now. The square root of x plus 2 squared is the absolute value of x plus 2. And the square root of 9 is 3. So that means that x plus 2 either equals 3, or x plus 2 is going to equal negative 3. Which means x is equal to 1, or x is equal to negative 5. And if you look at my picture, that seems like appropriate answers. So there's my x-intercepts. Now let's get the y-intercepts. To get a y-intercept, we're going to set, you guessed it, x equal to 0, because every point on the y-axis has an x-coordinate of 0. 0, 5, 0, negative 7, 0, 3, 0, 0. So we'll go back to the original equation and we plug in 0 for x this time and solve for y. Alright, so when I squared the 2, that's 4, and I'm going to subtract that to the other side, which is going to give me 6. 10 minus 4. And then I have y minus 1, quantity squared on the left still. Once again here, I'm not going to square it and try and solve a quadratic. I'm going to take the square root of both sides. And I get the absolute value of y minus 1 equals square root of 6. That's some decimal, so I'm just going to leave it as square root of 6. So that means that y minus 1 equals positive root 6, or y minus 1 equals the opposite of the square root of 6. And then if I add 1 to both sides, for the left equation, I'm going to get y equals 1 plus the square root of 6. And in the other equation, I'll get 1 minus the square root of 6. Those are the exact answers, so we're going to leave them like that. If you want the decimal approximation, grab your calculator and check. A shorthand way of writing this would be 1 plus or minus the square root of 6. And that would be fine as well. Okay, so you should have a pretty good idea of the equation of a circle. Given the equation of a circle, how to find the center and radius. If it's not in standard form, complete the square and put it in standard form. And if I give you information, be able to come up with the equation. So, here's the problem set. I've got an assignment set up for you to upload your assignment into Schoology when you're finished. And please upload that as a PDF. And there's also the skeleton notes in Schoology as well for this lesson. Take care.